You're building a web app and suddenly you see a request from origin has been blocked by CORS policy. And if you're asking what the hell it is, well, it's a browser feature, a bodyguard that you might not know even existed. CORS stands from Cross-Origin Resource Sharing, which is a browser security feature that by default blocks any calls made from one origin to another. It is there to protect users from malicious sites that are trying to access different resources on domains that they do not have permissions. For example, a malicious site like realbank.com, which is a copy of your bank's legitimate site, will not be able to trick you into calling your bank's API to transfer money or collect account information. Well, if configured correctly. So you see, when browser detects a cross-origin request, before making a real call, it will send a pre-flight options call, which will include the origin and all the necessary headers. The server then must respond with appropriate CORS headers. For example, access control allow origin will include origin that is allowed to make call to this service. If the origin will include a wildcard or the origin from which you made the request, a browser will allow the next request to be made to the server. But if the server will not include your origin in the response header, it will be blocked by the browser as it is violating same origin policy. And remember, CORS is a browser feature that is applicable only on websites running in legit browsers. It will not prevent any server-to-server communication or calls made by Postman or Coral. Okay, let's start with this simple example. We have some sort of banking application, and we can see that there is a checking account, savings account, and a credit card. And all of those balances are currently returning error, and we want to populate those values from the backend. Of course, it's a simple REST call to the backend service to get the information back. And there, for the server, we have a simple HTTP server written in Java that is listening on port 81, that is handling any request. We were logging what is being sent. Then, if the request is /balances, we know that this is the one that we want to return the balances for those fields, and we just respond with some mock response back. Quite simple. So it's 200 HTTP response with this following JSON structure. And as for frontend, we can see that it's simple consuming of our endpoint. We're calling the get to this /balances. And if everything is okay, we display the numbers, but if there is an error, we show the error and console output that there was some issues fetching the balances. By refreshing the page, you can see that there are errors in our balances, and from the code you saw that it only happens when there was a network issue, so we replace everything with errors. Now if we open the console, we can see indeed there was error fetching the balances, but the real reason is a bit higher. So you can see we are trying to access the local host from the originbank.com. It means we are crossing the origin. That's why it is being blocked by CORS by default. Why? Because the no access control allow origin header is present. It means that server has not allowed this origin to call itself. So one way how we can solve this is to put the backend and frontend on the same origin. So there are no cross-origin violations, and we are blocking any other origin from accessing it by default. But it's not always practical or feasible to do, because your resources could be located on different machines, and it means you would have to set up some gateways, proxies to have the same origin. In reality, the backend is not the only resource that you're accessing. You can be accessing some styles from different resources, like bootstrapping, just importing it with the CDN. It is accessing on different domain the CSS resource. Same goes for images, fonts. So we should have some sort of mechanism to control what can be allowed and what can be denied to accessing our resources that we deploy. Instead of relying that our resources will be on same origin, let's configure it properly to support multi-origin approaches. So let's quickly recap the flow. So frontend is trying to send a request to the backend. First, it will send a pre-flight with the origin from which it is calling. The backend is responsible to respond with the header that is either including your origin or not. If the origin is included, then the browser will allow it. If not, it will be blocked by the CORS policy. Okay, let's start with the easiest scenario. We will set the header to a wildcard. So let's get the response headers, and we will put our access control allow origin and set it to wildcard, meaning that any origin can call our backend. Let's refresh the server. And now everything works. The backend communicates to frontend, there is no error, we can close the ticket, and we are good to go. Well, not really, because now any origin or any malicious website can call your APIs directly from the browser. So they could create a malicious site. For example, I could, instead of bank.com, have a malicious site, realbank.com, that is pretending to be the same bank that you own. And you can see they also have displayed everything in their page because their origin is allowed. Well, you can argue we will have some sort of different protection like tokens, cookies, sessions, but what will stop them from creating the same malicious logging page that will collect the token and use it in the further calls? And that's why we want to stick to the least privilege principle and allow only necessary origins to accessing our service. Of course, if you're not intending opening your endpoints to the whole world. But before we start, let's actually define what is an origin so we know what we are crossing. So by the standard, the origin is defined as a triple of 3 values making a unique combination. A schema, so it's either HTTP or HTTPS or any other. Host, to which we are calling. And the port. Port is also part of this origin definition. So now if we would have this http example.com some sort of page, we can see from this table what is allowed or not. So if you look at the first example, it's another page. It is successfully allowed because it has the same schema, it has the same host, and also it has the same port, which is being omitted here. So if we go to the different path, same, still the schema, host, port are not violated. And if we include the credentials, remember still, if the 3 elements are not violated, the schema, host, and port, it will go through. But if at least a port, a schema, or a host is different, we will be blocked by the CORS because this is this origin definition being crossed. So now let's update this header to only allow proper access from our real bank application. So the schema was HTTP because it's hosted locally. I will not set the certificates. The host was bank.com and the port is default 8080, which we can omit. So now refreshing the page of bank.com, you can see that everything is okay. We have still received all of our balances. But if we will refresh the real bank.com, we can see an error, and if we will open our network and reload, we can see, okay, we have in the request set that origin of this caller is our this real bank.com, but response from the server has included the access control allow origin header, which is set to bank.com. And because these values are different, we are crossing the origin, we are not allowing it, thus it is being blocked. And now great, we have configured CORS properly, allowing only one origin accessing our backend service. But what if we would like to include multiple origins? For example, we would like to provide our resources to different pages for different clients. Well, we would need to configure that on our backend side. So usually instead of hard coding some origin, we would like to have some sort of allow list where we could look up if the origin is present, we then allow it. So let's make here some sort of hard coded list, which in reality could be picked up, for example, from the configuration file, allowed origins. And let's have here some list of origins that we allow. For example, bank.com, and let's for testing purposes add for now this real bank.com. So instead of hardcoding this origin, we would like to find out what was the origin of the caller. So let's get the exchange, the request headers, and we want to get first origin property. And here we need to be careful because get first could return null if the key is not present. Well, but a strange case, how it can be that origin is not present? Well, actually, if you call it from curl or postman, the origin header will not be set. So we could do a non-null check here. So if origin is not equal to null and our allowed origin contains this origin, then we want to set the access control allow origin. Instead of this hard-coded value, provide the origin of the caller. And now if I open again the bank.com, refreshing it, everything is okay, because on the network, in the response of this balance, we can see that the access control allow origin has been sent to the bank.com. And same goes for the real bank.com. If we now refresh, everything is okay. And because when we open this one, it is set dynamically to the real bank.com access allowed origin. And now if I will remove this real bank.com from the allowed origins, refresh it, and reload the page, we can see we receive a CORS error. And success, now we have more control of which origins are allowed to call our backend service. Okay, sounds like we're done. Well, actually no. Right now everything was great. We have sent just direct get call and we retrieve the information. But in reality, request calls are not that simple. Usually we have also some headers to provide. For example, we want to provide authorization token, right? So let's set up something. So we now want to have here an authorization and provide some sort of token. And now refreshing the page, we can see that we end up with error again. But we have not changed anything in the origin settings. The origins are allowed, everything is fine. So if we reload the page, we can see the request was again blocked by the CORS policy, but now with a different reason. The request header field authorization is not allowed by the access control allow headers in the pre-flight response. So now when the pre-flight call has happened, we try to send the authorization header to the server, but the server did not include it in the access control allow headers that it is allowing us to send the authorization. It's basically saying, I'm not interested in such header. Do not even try to send it to me. So this is again to prevent malicious attacks or malicious things happening to our server from this browser. And in addition, we are actually setting a strict controlled request that we are interested to receive. So we don't want any trash. We want to have this call happening from only this allowed origin list with following headers included. So now let's allow some headers to be sent to our backend. Let's add access control allow headers, and we will list the values that we are allowing to. So one of them is authorization. And now refreshing the page, we can again see those balances displayed, meaning that request went through. And if we open the reload page, now you can actually see both calls. So first was the pre-flight, we're sending the options call, and it got response that for the actual request that the browser will make, I allow following headers. One is authorization, and I allow following origin. And when the call is happening, it is setting the origin, which is matching, then we are allowing it, and we are also allowing this authorization header. So it means if we add some different custom headers, for example, I don't know, some request ID or tenant ID or anything else, every time we will try to send it to server, it will be blocked by the CORS policy because server needs explicitly to allow such interaction. We need to add in this access allow headers the new headers that we want to expose. And you can see it again works. And now you're probably questioning what else can be configured. Well, we can open this great Mozilla article about the CORS, and you can see they have listed different headers that we can send. We already have talked about the access control allow origin. Now we have looked at the allowed headers, but you can see there is also access control allowed methods. So for example, if we change this get to a delete and refresh our page, we can see, as expected, it will be blocked because the method delete is not on the allowed methods response. But why did get work initially? Well, if you look at this header, actually it is by default allowing get head posts. So either you configure it or not, it will be allowed. But for any different method, you need to specify that you are allowing it. So here, for example, instead of these headers, let's set it to methods and provide delete. And now again, refreshing the page, we can see everything is okay because on the network in the pre-flight response, we have and delete in the list of the allowed methods. Of course, the get and head and post are also allowed by the default. So what else? Well, we can see there is access control expose headers. This header adds the specified headers to the allow list that can JavaScript in browser to access. So what does it mean in practice? Well, actually it is another way how we can control what headers are now exposed back to the browser. So if our server would set some additional headers, for example, I don't know, rate limit to inform the browser that you have 10 attempts left to make this call. And if you will refresh the page, you can see that from this request, we have exposed this X rate limit header. But when we will try to programmatically access those headers, for example, let's see what headers are actually sent from the response. So let's get the headers, let's get only the keys, and let's output headers received. So now again, without changing anything, I'm refreshing the page, opening the console, and you can see from the header received, it is only content length. So we don't see the X-rate limit. We know that it has been sent, we can see it here in the network tab. But for the security purposes of accidentally exporting some of these headers, for example, some sensitive tokens, we prevent JavaScript from accessing it. So malicious site won't even see those headers. Yes, technically they are here, but when they will process that by the JavaScript on the browser side, it will not be present. But again, if you want to include that, we need to provide it here in this access expose headers. And we want to set that we are additionally exposing the X-rate limit. So now refreshing the server, refreshing the page, we can see again everything is okay. And now we check the headers received and we see that X-rate limit is on the list. And again, of course, there are some sort of headers that are enabled by default. For example, content line, because we need to know how many bytes we need to read for our body. Expires, content type, is it application JSON, is it a text or byte array or anything else, cache control, content language. You can find everything here. So what else is there? Let's look at the access control max age. So this header indicates how long the pre-flight request can be cached. And we can use this header to set this caching time for the browser so it doesn't send the pre-flight request, because in reality most often the CORS configuration is not changing that often. And you can imagine sending additional code each time we are trying to access our backend service could at some point become costly, because the cloud providers do bill us by the network used. So here, for example, let's add this and put it for 10 seconds just to see it in action. Let's refresh it. And now let's look in our bank application. So when I refresh it, we can see the pre-flight has been sent. Now I refresh it again. The pre-flight has not been sent because it has been cached in the browser. And now 10 seconds have passed. We now can refresh the page and we can see the pre-flight has been sent again. So this can save us a bit of network traffic. And last but not least is allow credentials, which is basically saying should the sessions and cookies be included in the request to the backend. If set to false or missing, it will be stripped by the browser. Because in this multi-client origin situation, we do not want to handle different session cookies that they are sent by their customers or their users. We would like to keep it safe and do not expose such information to our backend, because we could accidentally log them, expose them, or leak them. So here, for example, we would like to take the headers and actually tell browser to set the cookie. And let's set some sort of value, session ID is equal to 123. Let's make same site to none and secure. So now we have basically said that browser needs to store this cookie. Let's refresh our backend. So now I refresh the page, we can see everything is okay. We have received the set cookie command, and we can open the cookie and see actually this session ID value. Here on browser, we can say now following. I want to include the credentials. So browser now will try to send the cookies to our server. For refreshing the page, we again get the CORS error because we are trying to expose the credentials to the service, which is not allowing them. And we can see the access control allow credentials is not set to true, that's why it was blocked. So if we want to get the cookie and allow the cookie to be sent, now here in the headers we need to enable it. Access control allow credentials and set it to true. And now if I will refresh the page, we can see no more CORS error. If we check the network tab, we in the request we can see the cookie is present, and if we check the backend and search for the cookie, it has been exposed to our backend service. So by this flag, you can control either to allow it or to deny it. And that's pretty much all of the headers that we can use to control what can be accessed or exposed by this CORS policy. And you can imagine that you can also have some sort of combinations, like exposing some part to some origin, but not exposing to other. allowing some methods for one origin, but disabling them for other. And pretty much that's all about the course. I hope you enjoyed such content. I tried to keep it as raw as possible. I wanted to have it as low level as it can be, so you understand the concept and the basics. Of course, the frameworks will do their own magic and you provide different ways how to configure the course, but the principle is the same. And if you enjoyed such content, leave a like, subscribe so you don't miss the next video. If you want to see something particular, please let me know down in the comments. Until then, as always, keep coding, and I see you next time.